Now in the last video for today, we're going to, instead of finding roots of equations, we're going to find zeros of functions. And again, some of these zeros might be imaginary. So what we're going to do in finding these zeros is we're going to use our calculator to find the rational ones that we can find. So we're going to go to the calculator and we're going to enter this into y sub 1. And again, I'm going to have to go back and forth because once again, I'm old and can't remember things. So I'm going to go to y equals and clear out what's there. So then we have x to the fourth plus x cubed minus 7x squared plus x cubed minus 7x squared. And I better go back, minus 9x minus 18. So, back here, minus 9x minus 18. Okay, so again, I'm going to graph this on the standard window to see what kind of zeros we can find on this. And it looks like we have one at -3 and another one at 3. So you can confirm that. So going back here, we've got -3 and 3. Okay, just to confirm, yep, 1, 2, 3, 1, 2, 3. Okay, and if you actually went through and calculated those, you would find that. So now what we're going to do is we're going to perform synthetic division with one of the zeros. And then do it again with the other zeros to hopefully knock it down to a quadratic. So I'm going to put the coefficients of that polynomial out here. 1, 1, -7, -9, and -18. So there are the zeros, and again, when we perform this, hopefully we get a 0 here. So we'll switch over to red, bring down the 1, -3 times 1 is -3, add these to get -2. There we get 6, -3 times -2 is 6, -1, +3, we get -6, -3 times -6 is +18, and we do in fact end up with a remainder of 0. Good. So that means that x plus 3 is a factor. So now what we've done is just knocked it down to a cubic. Constant, linear, quadratic, cubic. So then what we're going to do is perform synthetic division with the other 0, 3, because then x minus 3 would be a factor as well. So then, hopefully, we end up with a remainder of 0. Remainder again ends up under the constant in synthetic division. So we bring down the 1, 3 times 1 is 3. Add those together, we get 1. Again, we get 3. 2, 3 times 2 is 6, and we do end up with 0. So the quadratic that we have left is x squared plus x plus 2. So we're going to set that equal to 0. So what we've basically done is we've factored that by finding 2 of the zeros and then using synthetic division to find the last factor. So we're basically rewriting this as x plus 3 times x minus 3 times x squared plus x plus 2. Now this one, no factors of 2 add up to 1. So I would probably do the quadratic formula since b is odd. So with the quadratic formula, opposite of b over 2 times a, plus or minus, that's where the two solutions come from, b squared minus 4 times a times c is going to be 8 over 2 times a. So this becomes negative 1/2 plus or minus. We end up with negative 7 underneath there, so that's going to become square root of 7i over 2. So our other two zeros are negative 1/2 plus or minus square root of 7 over 2i. So those are the four zeros, negative 3, 3, negative 1/2 plus square root of 7i, 7 over 2i, and negative 1/2 minus square root of 7 over 2i. Okay. And lastly, okay, now I made some horrible, dastardly mistakes once again. So I'm erasing what we've done, okay, and we're going to start this problem over again. Now this one I have already graphed in y sub 1, and graphing on the standard window, I see that the zeros, rational zeros, are negative 1 and 2. So going back here, we got x equals negative 1 and 2. So we're going to perform some synthetic division here. We're going to start with the negative 1, the 0 of negative 1, and I'm going to write the coefficients here. And the thing to be very careful of is that you notice we're missing an x squared term. So we got to fill that place with the 0. We need to fill that place with the 0. So we're going to perform synthetic division to this again. So performing the synthetic division, we're going to bring the 2 down, multiply to get negative 2, add these two to get negative 5, 5, add them together to get 5, negative 1 times 5 is negative 5, add them together to get negative 6, and negative 1 times negative 6 is 6, 0. So now we've knocked it down to a cubic, constant, linear, quadratic, cubic. And then we're going to go to our other 0 of 2 and perform synthetic division one more time. So we're going to bring down the 2. We've got 4, negative 1, negative 2, 3, 6, and 0. So we're in luck. So the quadratic that we're left with is 2x squared minus x plus 3 equals 0. And there are no factors of 6 that add up to negative 1. So we're going to do quadratic formula once again. Opposite of b over 2a plus or minus square root of b squared minus 4 times a times c is 24 all over 2 times a. So we got 1/4 plus or minus. We got negative 23 under the square root, so that's going to be square root of 23. So there are our other two zeros, because we should end up with 4 by the fundamental theorem of algebra. We have 1/4 plus or minus the square root of 23 over 4i. So our four zeros are negative 1, 2, 1/4 plus the square root of 23 over 4i, and 1/4 minus the square root of 23 over 4i. And that is using our graphing calculators to find the rational zeros, and then using synthetic division to help us find the imaginary zeros.